Hi, this is Howie. In this video, we're going to focus on creating a graph from a series of data and then using the graph to solve a variety of problems. Let's first collect our data. In this example, I'm building a tower out of blocks. Each block is 8 centimeters tall. I'm going to create a table to record the data. One block has a height of 8 centimeters. Let's add a second block to the tower. 2 blocks stacked together have a height of 16 centimeters. Let's add that information to the table. I will continue to add blocks to the tower. As I do, you will notice that every time I add an additional block, the height of the tower increases by 8 centimeters. It is increasing at a constant rate because each block is the same height. 3 blocks, 24 centimeters. Let's add that to the table. And now a fourth block. 4 blocks, 32 centimeters. I now have enough information in my table to really grasp this pattern. Every time I add a block, I add 8 centimeters. So let's start using this relationship to answer a few questions. Question 1. How many blocks will it take to reach a height of 1 meter? Question 2. How many meters tall is 18 blocks? Question 3. The height of my room is 220 centimeters. What is the greatest number of blocks I can possibly stack? To answer these questions, I guess I can follow the pattern and keep extending out the table. That's definitely a possibility, but it's going to take me a bit of time and a lot of computation. There's a much simpler way to address all 3 of these questions at one time. It's this amazing tool. It's called a graph. You will notice it looks just like a coordinate plane. In this case, the x-axis represents the number of blocks, and the units along the x-axis increase by 1 block. Even though it looks to be counting by 2, it's skipping a unit each time. That's just so the numbers don't become too crowded. The y-axis represents the height in centimeters. The units along the y-axis are increasing by 10. In this case, you will notice that the numbers go up by 20 each time, but they're skipping a unit in between. Therefore, each unit is actually increasing by 10 centimeters. And of course, every graph needs a title. Let's call this one block stacking. On the right side of the screen, you will notice I added the table. We're going to plot all of this information on the graph and then use it to answer the questions. First, let's create points that we can plot on the graph by creating ordered pairs. We can create the ordered pair 1, 8 using the information that 1 block has a height of 8 centimeters. Let's zoom in to find the location 1, 8. Each unit along the x-axis represents 1 block, and each unit along the y-axis represents 10 centimeters. So to find 1, 8, we're going to have to put our point a little bit lower than the 10 centimeter mark. This will require some estimation. Let's use the data from our table to create additional ordered pairs, and then we will plot those on the graph as well. 2, 16, 3, 24, and 4, 32. Once again, we can zoom in to get a better look for those points. 2, 16, 3, 24, and 4, 32. And here's where graphs become so powerful. Even though we only have 4 points, we can find so much more information just using the data that we have. To start, connect all of these points using a line and extend the line all the way through the end of the graph. Every single place along that line can be used for information. Let's take a look back at question 1. How many blocks will it take to reach a height of 1 meter? Well, I know that 100 centimeters is 1 meter, so let me find 100 centimeters along the y-axis and then follow it across until it intersects at the line. The graph tells me that I will need between 12 and 13 blocks to reach 100 centimeters. 12 blocks would be a little bit short, so the correct answer in this case would be 13 blocks. Let's take a look at that second question. How many meters tall is 18 blocks? Let's start by finding 18 along the x-axis and following it up until it intersects the line. Now we can follow it across until it intersects along the y-axis. It looks like 18 blocks is just over 140 centimeters. In this case, the graph doesn't tell us an exact answer, but it can really help us estimate. To find the exact answer, we should do some computation. We know from our table that each block has a height of 8 centimeters. If we have 18 blocks, that's like counting by 8 18 times. That's what we could do if we were extending out the table. Instead, let's use multiplication. 8 times 18. 8 times 8 is 64. Let's carry the 6. 8 times 1 is 8, plus that 6 is 14. Therefore, our answer is 144 centimeters, which is written as 1.44 meters. That's pretty close to our estimate using the graph. Question 3. The height of my room is 220 centimeters. What is the greatest number of blocks I can possibly stack? Pause the video while you solve this question on your own. Then press play to check your work. Find 220 centimeters on the graph. We'll move across and then down to find out how many blocks we can use. The line falls right between 27 and 28. 28 blocks would be too much, so it wouldn't fit in the room. Therefore, the correct answer is 27 blocks.